to start up. Today we'll be dealing with the concept of matrices, and it will be an introduction to matrices. Now, first of all, what is a matrix or matrices, as the case may be? A matrix can be defined as a set of real numbers or complex numbers or elements that are arranged in rows and columns to form a rectangular array. So, in a more conventional form, we could just say that a matrix can be defined as as an array of numbers, or perhaps an array of elements or entities. Now, a matrix is called m by n matrix if it has m rows and n columns. Basically, so for instance, if I could, it would be of this form. It could be of this form. Say A11, A12, all the way down to A1m, or better still, n. Then A21, A22, all the way down to A2m. Then it could spine all the way down to AN1, AN2, all the way down to ANM. Either way you like it. Or if you want to make it alphabetical, you could just say that, okay, let's say be n, and you have it to be n, and perhaps you'll be having it to be m1, and say m2, and let's say mn, although it has no repercussion, but just for the sake of alphabetical order. Then I have my arrays of numbers. So each entity could be a real number, could be a complex number, or perhaps can just be an element, arrangement of an element. So we could just label this as capital A, or whatever you want to label it to be, but it will be bold. So this is how we represent a matrix. So this is referred to as what? A matrix, a m by what? A m by n what? Matrices. In that it has how many rows? It has rows. This is the rows, and this is each entity here is called the row. Either way, row 2, row m. Then here is called the column. So I have what? This row 1, row 2, row what? M. Then you have the colon what? Colon 1, colon 2, and what? Colon n, actually. So that we name this guy what? M by n matrix. It has m rows and n columns. So such a matrix is called m by n matrix. And apart from this, you could denote the whole of these matrices as Aij, as the case may be, and this I and J will be spanning what over a particular range of numbers, either real numbers or perhaps natural number, as the case may be. So that is that for a matrix. And basically, like I said, we're just going to be looking at an introduction into matrices. Now, again, is that there are various types of matrices. We have the row matrix, you have the column matrix, you have the upper triangular matrix, you have the lower triangular matrix, you have the unit, the identity matrix or the unity matrix, you have the idempotent matrix, you have the screwed matrix, you have the symmetrical matrix, and a whole lot of them actually, and even a null matrix that we perhaps be considering in this class, even though I tend to keep it short so I can just water your appetite for matrices. Welcome back to class once again. Now, if I have a matrix of this form, how do I label them? For instance, I have a matrix of this form. What kind of matrix is this? How will I label? What will I call this matrix? So what if I have a matrix of this form? What do I call it? A matrix of this form is called what? A matrix of this form, what is it called? What do I call this? What do I call a matrix of this form? And what do I call a matrix of this form? What will I call them? Now, by definition, the way we divide it from the beginning, I bring us into the knowledge of saying that we have, first of all, we label matrices, first of all, counting the rows, then the respective columns. So, first of all, from our arbitrary matrix, we talk about the m times n or m by n matrices. So, in other words, first of all, count the rows of this. we have just one row, two rows, that is 2 by, here does not literally mean times, it means by, how many columns? 1 column, 2 column, 3 columns. So this is a 2 by 3 matrix, a 2 by 3 matrix. Meanwhile, this is how many rows do I have here? I have 1 row, I have 2 rows, I have 3 rows. So it's 3 by what? 3 by 2 what? 3 by 2 matrix. So that is how we understand such. Now, what do I call this? How many rows does it has? It has just 1 row and 1 column. So we call this what? A 1 by 1 matrix. A 1 by 1 matrix. Meanwhile, we call this, how many rows does it has? It has just 1 row by columns. 1, 2, 3. It has 3 columns. So it's called 1 by 3 matrix. But in a simple term, we call it a what? A row matrix. Sometimes we call it what? A row matrix. This is referred to as a what? A row matrix. But here is called, how many rows does it has? It has 1 row, it has 2 rows, and it has a single column. It's a 2 by 1 matrix, or you call it just what? A colon what? A colon matrix. So that is that for that. That's how we label matrix. And I believe this will not be hard for you to do. If perhaps you are given something of this form to label, what would you have called this? What would you have called this? Now, literally, I know you must have known the answer. It is called 1, 2, 3, 1, 2, 3. This is a 3 by 3 what? Matrix. What does that imply? This is otherwise referred to as a what? A squared matrix. Now, what do we call a square matrix? A square matrix is a matrix that has equal number of rows as equal number of columns. That is to say that where is an m by n matrix such that our m is actually equals to n. A square matrix is actually a m by n matrix such that the rows, the numbers of rows is equal to what? The number of columns. Such a matrix is referred to as a squared matrices. The other cases of matrix we have to discuss very, very quickly. And we although we also have what we call the null matrix. It's called the null matrix. Why? Because it actually has all of its entities or entries to be zeros. All of its entities and entries are actually zeros. So we call it what? A null matrix. And then we have what we call the identity matrix, which we have something of this form. The identity matrix is otherwise known as a what? Don't forget, this is a null matrix as well as a square matrix. And you need not to be told why it's called a square matrix. In that all of its entries are zeros and the number of rows and columns are actually equal. Here it's called a square matrix as well as what? An identity matrix. Identity matrix because what? Because the numbers on the main diagonal is 1 and numbers of the main diagonal is 0. Such a matrix is referred to as what? An identity or unity matrix. Meanwhile, in the same vein, I could have matrix of this form. This is not an identity matrix, but it is called a diagonal matrix. Why? Because elements on the main diagonals are non-zeros, while elements of the main diagonals are zeros. So it is called a diagonal matrix. Or they say it is also a squared matrix because it has equal number of rows as to the numbers, equal number of what? Of columns as well. So it's called a what? A squared matrix as well. Also, there are other type of matrix that we need to deal with as well as we go on in the class. Welcome back to class. Now, the other type of matrix we are going to discuss is called the transpose matrix. The transpose of a matrix. Transpose of matrix. Now, what is the transpose of a matrix? In this case, you are given a matrix, and the case whereby you turn the rows of that matrix into the column, then when you turn each rows of that matrix into respective columns, then such a matrix becomes a transpose of a matrix. And given the matrix A, the transpose of matrix A is denoted by what? By AT. For instance, if matrix A is given to be, say, 4, 2, 5, 1, your transpose will be what? I will convert this down to column, so it becomes 4, 5, and this down to column becomes 2, 1. This is referred to what? A transpose, the transpose of matrix A. Meanwhile, if it was in the case, say B is actually, say, 2, 1, and 3, 3, 4, and 5, then the transpose of matrix B would have been that I convert all of these rows to be what? To become columns. All of these rows to become what? Column. So this is the transpose of this guy. So this is called the transpose of a matrix. But a symmetrical matrix is actually a matrix. Given a matrix A symmetrical matrix is a matrix has to be symmetrical if the matrix is the same as the transpose. That is to say, the case somebody are given a matrix A and you discover that after transposing it, it is equal to the main matrix A given, then we refer to such a matrix as what? As the transpose of a matrix. For instance, if you are given a matrix, say, let's say 5, 2, and here you are given 5, 2, and yes, you maybe say 2, 5, for instance. 5 to 2, 5. Then this is your matrix A. Then you're asked to find the transpose. What do you have? This becomes the colon. I have 5, 2. This becomes the colon. I still have 2, 5. Such a matrix is called a symmetrical matrix in any case. And even though it was a 3 by 3 matrix, you'll have asked something of this. Some say that you have a matrix B to be, let's say 1, 2, and let's say minus 1. And let's say 2, 5, let's say 6. And let's say here to be minus 1, 3, and this is just for instance. Okay, let's here be 6, and let's here be 2. So such a matrix can be referred to as what? As a symmetrical matrix. In that, when you are to find the transpose of this matrix B, you discover that this guy becomes 1, 2, minus 1, then 2, 5, and 6. Then this guy comes here, minus 1, 6, and 2. Nothing is changing. So it is referred to as what? As a symmetrical matrix. We have just talked about the transpose of a matrix such that what? You turn the rows to columns, and a symmetrical matrix is a matrix such that what? Such that even after you have transposed it, it still looks the same as the original matrix. In case of a screwed matrix, I have a matrix A. Then if I have a matrix A, so that after transposing it, I'm having a minus A transpose, then this matrix is not a symmetrical matrix because of this minus, but it is referred to as what? As a screwed what? A screwed matrix. It is a screwed matrix. Let's just try to transpose this. When I transpose this, what do I have? I have it to be what? To be 0, 2, and 5. And I have it to be minus 2, 0, and 9. And I have that to be minus 5, minus 9, and 0. I discovered that they almost look the same, only that if I actually factorize the minus symbol, so that I have 80, it's going to be what? It's going to be 0, minus 2, minus 5, then 2, 0, minus 9, then 5, 9, and 0. Now, looking like the former one, in that what I factorize minus out of this guy, so it is called a symmetrical matrix. Is called a symmetrical matrix in that case. So the next simple thing we're going to be discussing is called the addition of matrices, which is simple, but there are some terms and principles we have to follow. Now, when it comes to addition or subtraction of matrix, let's talk about it simultaneously. We discussed the fact that when you're adding two matrices, say A and B, both must be of the same dimensions. Dimension in the sense that they must have the same row and same column for the concept of addition or subtraction to be possible. Both must contain both must be of the same dimension for the concept of addition or subtraction to be possible. What do I mean by that? I cannot add a 2 by 3 matrix to a 3 by 2 matrix. I cannot add a square matrix to a column matrix. I will only add a square matrix of the same dimension to another square matrix of the same dimension. Otherwise, it is called impossible to solve. Now, for instance, we have the example on the board. We have a 2 by 2 matrix added to a 2 by 2 matrix. We expect that it gives us a what? A 2 by 2 matrix. That is 2 plus minus 1 will give me 1. 5 plus 2 will give me 7. 4 plus 3 will give me 7. 1 plus 1 will give me 2. A 2 by 2 matrix. Meanwhile, adding this together, what do I have? Minus 1 minus 5 give me minus 6. 0 minus 1 give me minus 1. 3 minus 2 will give me 1. Then 3 minus 0 will give me 3. A 2 by 2 matrix. Also, I have this added together. A 2 by 2 matrix added to a column matrix will give me impossible. It cannot be added. Why? Because they are not of the same dimension. If they are of the same dimension, it should have been easy to actually tackle in the reason. Welcome back to class. I feel the need for me to give you an explicit interpretation of what this guy stands for. even though I know I gave a brief from the beginning of the class. In that, I said each of these guys are called elements, which in themselves could be what? In which each element can either be what? A real number, or perhaps a complex number, or just call them what? An entity, or an element. Now, this guy, this single guy, represents something. It represents elements on the first what? On the first row. That is what this one implies, and on the first column. While this guy implies elements on the first row and on the second column. While this guy implies elements on the first row and on the nth column. This guy implies elements on the second row and on the second column. This guy implies elements on the mth row and on the what? And on the second column. So that's how simple it can be, just as I bring into light of what these things implies. Now, the next thing I'm going to be discussing again in this class, then perhaps in the next class we'll discuss other things. This, granted of this class, we're going to be talking about the determinant of a 2 by 2 matrix. Basically, in our next class, we're discussing for 3 by 3 or perhaps for higher matrices, and the inverse of matrix, and how to use matrix in solving simultaneous equations and system of linear equations. We're going to be discussing that. Just stay put. But for this class, we're going to be discussing the determinant of what? The determinant of a 2 by 2 matrix, actually. Now, in determinant, we actually typify the symbol of determinant to be just 2/ implying just like a modulo symbol, but not talking like modulos actually, behind the denotation of a matrix. That's what it implies. For instance, I have find a matrix A. You are given a matrix A to be of the form, say 2, 3, 4, and let me say 5, for example, and you're asked to find the determinant. All you need to do is so simple, is that your determinant simply becomes A, that's change, become what? 2, 3, 4, 5. Please take note of this symbol. I have a plus here, I have a minus here, such that my A is equals to cross multiply. I have plus and minus, that's what we denote it at. It's called determinant. Plus and minus, here is minus and plus actually. So, here is minus and plus actually. So, I have here to become what now? 2 times 5, then minus, this minus here, 3 times 4. So that it becomes 10 minus 12, which equals to minus 2. That is the determinant of that matrix. And if I have to solve for the determinant of a matrix B to be equals to, let's say, 5 and 2, let's say 3 and minus 4, what do you have? A plus and a minus. The determinant of matrix B is then equals to 5, 2, 3, minus 4. Then you cross multiply. Then I have B to be here to be equals to 5 times minus 4, minus 2 times 3, because I have a plus and a minus here. So minus 20, minus 6, and that is minus 26 as the determinant of our matrices. So in our next class, by God's grace, we're going to be discussing another concept under matrices, and I sure do you're going to enjoy it. Ensure that you subscribe, and so that you can get the notification when we post a new video.